All right, doo-wop doggy dogs. Make sure on page 4 it says notes at the top. Quick review of inequality signs. Now some of you might remember the Pac-Man chant. I'm actually going to teach you another way to remember how to draw your inequality signs that might help even more. Let's look at our first two values, 424 versus 5,249. Well, we know, because there's a 5 in the thousands place here, that this number, 5,249, is greater. So we're going to put two dots next to the larger value, just like I did there. Draw two dots. And the smaller value only gets one little dot, because it's smaller. It gets one dot. And then just connect your dots, bloop, bloop, and you have your inequality sign. That easy. Look at the next value, 345 versus 354. Well, the hundreds place is the same for these, the 3 and the 3. But look at the tens place. One of them is 4, one of them is 5. So on your own, draw the inequality sign for these values. If you said, well, I should make two dots next to 354 because it's larger, and one dot next to 345, you're correct. Connect your dots just like that. Okay, and our last one here, we have 3 9/10 and 18. Well, because there's a decimal right here, we know there's something in the ones place and something in the tens place. But this 18 is something in the tens place. So this number is larger. 18 is bigger. So put two dots here, one dot next to 3 9/10, and connect your dots. Example 1. Use the models provided to represent the decimals shown. Well, the first decimal is 0 and 3/10. Since my model split into 10 sections, I'm going to shade 3 of them using my fancy dancy pen. I'm going to make them green. So shade in the first 3. 1, 2, 3. Just like me. Nice work. Well, now next to that, we have 0 and 30 hundredths. Well, my model split into 100 sections, and I need to shade in 30 of them. So I'm going to use a blue pen here and shade in the first 30. Well, each row is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we need to shade a total of 30, so that would be, the next row would give us 20 total, shade it in, and then the next one would give us 30. So carefully shade in the first 3 rows of your model. Splendid. Thumbs up if you've got your 2 models shaded in. Mr. Phelps, in real life, you should scan the room and see what they're ready. All right, so if they're equivalent, that's the question off to the right. Well, equivalent values represent the same amount of space, the same value. So if you look at 0 and 3/10, and then our number at 0 and 30 hundredths, the same amount of space is shaded in, so these values are equivalent. Circle yes right there. Yes, they are equivalent. Now let's scroll down to our next 2 values. The first one we have is 0 and 7/10. Well, I'm going to take my green pen again, and it's 7/10, so let's shade in 7 of these rows. 1, 2, 3, 4, 5, 6, 7. I'm going to go back and make this look a little prettier here. Shade this in on your paper, the first 7 rows. Okay. All right, nice. So that's 7/10. Well, now the number to the right of that, whisper to your neighbor, how would you say this value that I'm about to circle in blue? How would you say that? Whisper to your neighbor. Go. If you said 0 and 7 hundredths, you are correct. Nice job. So here, our model is split into hundredths, 100 different pieces, and I have to shade in 7 of them, because it's 7 hundredths. Well, I'm going to take my blue pen now and shade in 1, 2, 3, 4, 5, 6, 7. All right, there's my 7 hundredths. Okay, So we have our 0 and 7/10, and we have our 0 and 7/100. Quickly, thumbs up or thumbs down. Are these two values equivalent? Thumbs up, yes. Thumbs down, no. If you said no, you are correct. These values are not equivalent because they don't take up the same amount of space. They represent different values, different amounts. Well, if we look at our first two numbers again, 0 and 3/10 and 0 and 30/100, they were equivalent. But our next two numbers were not, 0 and 7/10 and 0 and 7/100. What is different about these values that makes them either equivalent or not equivalent? So we've learned the placement of the 0 is really important in determining if a number is equivalent or not. Let's look at example 2. Complete the models for the values given. Compare the values using less than, greater than, and equal to. Well, first it says shade in 0 and 4/100. Take your pencil and let's do that. 400, so shade in 1, 2, 3, 4/100. Okay, done. Next one. Shade in 0 and 44/100. Oh my goodness. Okay, so I'm going to shade in the first row. That will give us 10/100. The next one will give us 20. Next one gives us 30. The next one is 40. And the next one we should do 4 more. 1, 2, 3, 4. Okay, so that's a total of 44 boxes shaded in. So that's 0 and 44/100. The last one says shade in 0 and 4/10. Well, we can still do this, but it's a little tricky because our model is split into 100 pieces. Well, we know when we look at our tenths model, I'm going to scroll up just a little bit, the tenths were this entire row. So if we wanted to shade in 1/10 on this model, we would shade in this entire top row. That is 1/10 of the entire model. Count to yourself. How many hundredths did we shade in to make 1/10? If you said 10 hundredths are in 1/10, you're correct. Well, I need 0 and 4/10. So let's shade another tenth. This would be 2/10. Another row would be 3/10. And another row would be 4/10. Okay. How many hundredths did we shade in to show 4/10? If you said there's 40 hundredths and 4/10, you're correct. You can also imagine if we took 0 and 4/10 and we added a 0 to the right of 4, you can see it's the same as 0 and 40 hundredths. It's another way to solve. So we're not done yet. Now the question says, fill in the blanks below using less than, greater than, and equal to. Annotate that question. And look at our first comparison. This one is 0 and 4/10 versus 0 and 44/100. Well, let's look at our model. Here is the 4/10 on the very right, and 0 and 44/100 is in the middle. Which one do you think is larger, silent hand? Well, I agree. 0 and 44/100 is larger. So put our 2 dots next to that, and put 1 dot next to 0 and 4/10 and connect those dots. So now this sentence reads, 0 and 4/10 is less than 0 and 44/100. Try the next two on your own, and then check your work based on what Mr. Phelps shows. Go. Hey, good morning, Ms. Pinales. You're a star on our video now. It's good. All right, so now check your work with what I've got on the second and third box. Moving on. Last example, 3. Use the place value chart to compare the values using less than, greater than, or equal to. Well, this time instead of a model, we're going to use our chart. Take each digit and write it in the correct spot. 638 and 34 hundredths. And then write your next one. 638 decimal point 43. To compare values using this chart, we start from the far left, the largest place value in the digit. So, well, we've got something in the hundreds place, but they're the same. So give them a check if they're the same. In the tens place, we have both of them have 3s, put a check mark. In the ones place, they both have 8s, checkity check. Then they both have decimal points, don't care about that. Tenths place, oh, here we go. Look what's different. In the second value, there's a 4. In the first value, there's a 3. So circle the 4, because that tells you that it's a larger number. We don't even have to look at the hundredths place, because the tenths are different. So this means the second value is larger. So put 2 dots next to the second value, 1 dot next to the smaller value, and connect those puppies. 638 and 34 hundredths is less than 638 and 43 hundredths. Try the same thing on option B. Solve it on your own, then check your work with me. Go. If you said 8 and 39 hundredths is greater than 8 and 299 thousandths, you are correct. Now, don't make this mistake. It's kind of a common mistake. Some people might see this value, the one I'm boxing here, and think, oh my gosh, there's more digits. There's an 8, a 2, a 9, and a 9, so it has to be bigger than our first digit, our first value, that only has 3 digits, an 8, a 3, and a 9. Well, that is totally false because of where the decimal point is. You must look at the place values to determine which number is greater or smaller. Nice job.